Notice we do not have a common term in both equations. Because of this, substitution is a little bit preferred here. So remember, in substitution, the first step is to solve for a variable in one equation. So looking at those equations, of those two equations, which one do you think would be easier to solve for a variable? Second one, because both variables are linear. So what variable do you want to solve for? It does not matter. X it is. So if we took the second equation and solve for x, we would get x to be equal to 2 over y. So substitution, solve for one variable in one equation, and plug that expression into the same variable in the other equation. So instead of the x in the first equation, we're now going to put 2 over y. Everything else copies down. So now notice we have an equation of just y's. Let's square out that 2 over y. We'll get 2 times 4 over y squared plus y squared equals 6. Two times 4 over y squared would be 8 over y squared. Now what do you think we do? What do you mean by take out? You mean get them on one side of the equation? We can. But we'd have to take this entire fraction and subtract it out. We can't just take the y squared. Yeah, let's clear out that fraction. Let's multiply everything by y squared. So what is y squared times 8 over y squared? 8 plus y to the 4th equals 6y squared. Good. Now let's get everything to one side. We're going to subtract 6y squared. This is an equation that's quadratic in form. If you want to do a substitution, you can. If not, let's just straight up factor it. Give me two numbers that would multiply to positive a, but add to negative 6. Good. And then what would go here? Y squared. So y squared would be 4. So y would be what? Plus or minus 2. Y squared would be 2. So y would be what? Yep. And that's y, but now we have to find the corresponding x's. If y was positive 2, then that means x is 2 over 2, because we're just putting 2 in for this y here. So what does x equal? 1. So what's this ordered pair? 1, 2. If y is negative 2, then x is 2 over negative 2, which is negative 1. So negative 1, negative 2. If y is the square root of 2, then x is 2 over the square root of 2. Which is 2 square root 2 over 2, which is square root of 2. because you have to rationalize. So this would be radical 2, radical 2. And then notice if y was the negative square root of 2, doing the same process, you'll get x to be negative square root of 2 by rationalizing. So the last order pair is negative radical 2, negative radical 2. Hooray! What is the first graph, by the way? Ellipse. It's going to be a vertical one. What is the second graph? Oh, let's see who remembers. If I were to solve for y instead of x, I would get y equals 2 over x. It's your reciprocal function. So it's doing this kind of thing. So there's your 4 points of intersection. Good times.